In this first question, I'm always going to separate the numbers from the variables. So I'm dealing with 4 over 2, and I'm simplifying that fraction. And then separately, we'll look at how we simplify x to the power of 3 divided by x to the power of 5. Of course, we'll write the answer as a single fraction. 4 divided by 2 is 2 over 1. So I have a 2 left in the numerator and a 1 left in the denominator. When I look at x to the power of 3 divided by x to the power of 5, I can absolutely use my properties of exponents, or I can think of this as 3x's multiplied together in the numerator and 5x's multiplied together in the denominator. That shows me clearly that I can cancel 3 pairs of x's from the top and the bottom and leaves me with 2x's multiplied together in the denominator. And let's try one last time. These 3 examples are a little more basic than what you would see on a module test, but they're a great place to start. In the first question, we have numbers and just x's. So we can simplify the numbers separately from the x's. We think of this as 4 divided by 2 as a separate problem from x to the power of 3 divided by x to the power of 5, although we will write the answer in a single fraction. 4 divided by 2 simplifies to 2 divided by 1, so that shows us that we have a 2 remaining in the numerator. For the x's, while we can use our properties of exponents, we can also think of this as 3x's multiplied together in the numerator, and 5 in the denominator. That clearly shows us that we can cancel 3 pairs of x's, and we're left with 2x's in the denominator multiplied together, which gives us x squared. So there's our simplified version of the first example. In the second example, we've got numbers, 14 and 7, but 2 different variables. So we'll treat these separately. So looking at the numbers, I have 14 and 7. 14 divided by 7 is 2, or I can think of it another way. I can think of it as the numerator and the denominator both being divisible by 7. 14 divided by 7 is 2. 7 divided by 7 is 1. Either way shows me that I have a 2 remaining in the numerator. In the denominator, I have x to the power of 2. It's the only x, and there's no negative exponent, so that x to the power of 2 will remain in the denominator. But the y in the numerator is raised to a negative exponent, and again, the negative exponent means we'll pick up the base and move it to the denominator. So there's our final answer. And with the remaining problem, I'm going to focus first within the brackets. Although we could apply the -1 right away, often our questions are much easier to solve, much more straightforward, if we can simplify within the brackets first. So we'll do that here as well. Again, I'll look at the numbers and the letters separately. Here I have 2 over 4, and once again, when I write that as a reduced fraction, I get 1 over 2. Again, it's as though the numerator and the denominator are being divided by the same value. That's exactly what's happening. 2 divided by 2 is 1, 4 divided by 2 is 2. So inside that bracket, I know I have a 2 remaining in the denominator. I've got an x in the numerator and a y in the denominator, and for the moment, there's no reason to move those. Themselves, they're not raised to the power of -1. That -1 is on the outside of our brackets. So I'll write x in the numerator, y in the denominator. As we discussed on the previous slide, now every single thing inside the brackets, the x, the 2, and the y, are raised to our exponent, which means that the x, the 2, and the y all move to the other side of the fraction line from the one they're on. So our final answer is 2y over x. Here we dig into some more involved examples. On the left-hand side, again, I'm going to look at the numbers 6 and 2 separately from the x variables, x to the power of 3 divided by x to the power of 4, and then separately look at y. So I can think of this in three very separate parts. Simplification of 6 over 2 gives me 3 over 1. X to the power of 3 divided by x to the power of 4. If I cancel 3 x's from the top and 3 x's from the bottom, leaves me with 1 over x to the power of 1. And y to the power of negative 1, well, that would ask me to take the reciprocal of y. But y is in the denominator at the moment, so it wouldn't end up in the denominator. Rather, we'll pick up the y and move it to the numerator. So let's put these pieces together. 6 over 2 gave me 3 over 1, so we're left with a 3 in the numerator and a 1 in the denominator. X to the power of 3 over x to the power of 4 leaves us with an x in the denominator, so I'll add the x into the denominator. And because y is raised to the power of negative 1, we pick up the y and move it to the numerator. Moving on to questions that have a little bit more going on in terms of the exponent outside of the bracket. But as I mentioned on the previous slide, we want to be careful to simplify inside the bracket first. It'll keep our numbers smaller and help ensure that we don't make any errors. So looking just inside the brackets of the second question, I've got 4 over 12 and x to the power of 4 divided by x to the power of 1. So in particular, where the larger exponent is in the numerator, it's quite easy to use the properties of exponents. So I'll rewrite this as x to the power of 4, and I'll subtract the 1 because we have x to the power of 1 in the denominator, and that leaves us with x to the power of positive 3. This x, the way it's written, is in the numerator. The exponent is positive, so at the end of the day, the x will stay in the numerator. So we have x to the power of 3. I've skipped over 4 over 12, but we can simplify that as well. I notice that 4 and 12 are both divisible by 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. So 4 over 12 simplifies to 1 over 3. So we don't need to give the 1 in the numerator because we already have an x cubed there, so we don't need the 1 placeholder, but we certainly need to add the 3 into the denominator. All right, there's nothing else we can simplify inside the brackets, so it's time to raise everything to the power of 2. So we have x cubed, we'll raise that to the power of 2, and 3 in the denominator, also to the power of 2. So where we've got x to the power of 3 and we're raising that to the power of 2, we need to use the property of exponents that lets us take the 3 already raised to a power and raise it to an additional power. If we look at our rule, it tells us to multiply our exponents. So we get x to the power of 3 times 2, or x to the power of 6. So the final answer, I'm going to write it to the right here. We have x to the power of 6, and 3 squared we can evaluate. 3 squared is 9. Again, I encourage you to pause these videos, try it on your own, and then check out the answer as I catch up. And again, I'm going to ignore the outside entirely, and we're just going to worry about simplifying inside the brackets. So we've got 28 over 18. So this is the first example where it's not going to simplify to either a 1 in the numerator or a 1 in the denominator. But what factor goes into both 28 and 18? 18 is divisible by 9. Going to have to stop, but I notice that they're both even numbers. And the largest number that goes into both is 2. 28 divided by 2 is 14. 18 divided by 2 is 9. So we have left 14 over 9. So in terms of the numbers, I have 14 in the numerator and a 9 in the denominator. And in terms of the x's, I have 3 x's in the numerator and 1 x in the denominator, so I can cancel 1 from both top and bottom, and I'm left with 2 x's in the numerator. And of course, there would be a 1 in the denominator but we don't need to write that. So I've got 2x's, x squared in the numerator. Okay, and as a last step, I'm going to raise everything to the power of -1, which simply tells me that the 14x squared will end up in the denominator, and the 9 will end up in the numerator. Here we have 2 more examples with brackets, a couple negative exponents inside the brackets or outside the brackets, and some negative numbers. A good time to remind you that regular negative numbers like this -3 and this -4 behave the way we expect them, as negative values. It's the negative exponents that have a particular meaning. As soon as we see a negative exponent, it's not your usual negative number. It has a specific instruction associated with it, and that is to take the reciprocal. So we need to stay aware of that throughout. Much like the last page, I'll look at the numerical values separately from any variables. So we have -3 over 27. So that negative is going to stay, or I could write it out in front of the fraction. It's up to you. Maybe this time we'll leave it in the numerator. So let me tidy this up before we get too much further. I'll draw a single fraction line, and of course this will still be in brackets and all raised to the power of 2. -3 and 27 I recognize as being divisible by 3. -3 divided by 3 is -1, so I'll have a -1 in the numerator. 27 divided by 3 is 9. So now, of course, if that 1 is not the only thing in the numerator, the 1 won't stay there. All right, so I have x to the power of 2 and x to the power of -3 to look at. So there are different ways I can do this. I can apply the properties of exponents right away, or I can recognize that this x to the power of -3 simply means that I'm going to pick up all 3 x's and move them to the numerator. So there were already 2 x's in the numerator, and now I'm picking up the 3 x's in the denominator and likewise moving them there. Now the property of exponents that I'm going to use is one where I multiply my bases together, and therefore I get to add the exponents. 2 plus 3 is 5, so altogether I have 5 x's multiplied together. Where are they? Look at them. They're in the numerator. So I have x to the power of 5. Another way to look at this is to apply the rules for quotients immediately. So we can say, okay, I'm dividing 2 x's. I'm going to take the top exponent, the 2, and subtract the bottom exponent. So I'm going to subtract -3. So I have x to the power of 2 minus -3, which is the same as 2 plus 3, which is x to the power of 5. So regardless of your approach, you're going to end up with x to the power of 5 in the numerator. As a next step, I'm going to raise everything to the power of 2. I'm not going to worry about that 1. In fact, I can just eliminate it. So I've got a negative x to the power of 5. I'm raising that to the power of 2. And in the denominator, a 9. And I'm raising that to the power of 2. So the negative here is also being raised to the power of 2. Negative times negative is positive. And x to the power of 5 to the power of 2. So that's x to the power of 5 all to the power of 2. What does our rule tell us to do? It says in this situation we're going to multiply those exponents. So we get x to the power of 10. The denominator, 9 to the power of 2, or 9 squared, is 81. And that's the end of this first problem. We're going to tackle this second problem very similarly. Let me use a different color so it's easier to distinguish between the scratchings from the 2 different problems. So again, I like to do a little bit of extra material as we work towards our final answer. So this is a good time for me to remind you that our processes may look very different. There are a number of different ways here that I've shown you how to get to the answer. I would like to see some intermediate steps, right? So we do want to show some of our work, But as long as we all get to the same final answer, there are lots of different routes we can take to get there. That's true in all of algebra. It feels especially true for exponents. We're all going to see these problems in a slightly different way, and I encourage you to try different approaches and then use the one that you're most comfortable with. All right, but again, I really just like to simplify inside the brackets first, so I'm going to strongly advocate for that approach. -4/2 simplifies to -2/1. So we have a -2 in the numerator, and there will be a 1 in the denominator, but we may not need to write that if there's something else in the denominator instead. And of course, if 1 is the only thing in the denominator, we won't write it either. So I'm just giving these as placeholders for now. Now, x to the power of 3 divided by x to the power of 5. Again, that's 3 x's in the numerator and 5 x's in the denominator, which means we can cancel 3 pairs and we're left with 2 x's in the denominator. I wanted to draw that one out again because I'll show you what this looks like if we use the property of exponents instead. So we know that the answer is 2 x's remaining in the denominator, so x squared in the denominator. Okay, but what happens if we use the property of exponents? Well, we write down a single x, and where is this x? The way I've written it, it's in a numerator, right? It's x/1. And then I'm going to take the top exponent, the 3, and subtract the bottom exponent. So we get x to the power of 3 minus 5, or x to the power of -2. Nobody likes negative exponents, mathematicians in particular, so we're going to rewrite all of our answers so that we have only positive exponents. So our x to the power of -2 becomes 1 over x squared. So we have exactly the same answer as we found in the first attempt. All right, once again, I'll get rid of that 1 because it seems to add just complication. And now I'm going to suggest that we deal with this -3 in 2 very separate steps. So again, this -3 is very much the same as having an exponent of -1 as well as an exponent of 3. So we have 2 separate instructions. What does the -1 tell us to do? It tells us to flip everything inside the brackets, to flip that fraction, to take the reciprocal. So that's exactly what we're going to do. So the x squared ends up in the numerator, and the -2 ends up in the denominator. So we've used the -1, but we have the 3 remaining. So I'm going to rewrite the 3 on the outside. Similarly, you could raise everything to the power of 3 first and leave the -1 on the outside. All right, so now we have x to the power of 2, and we'll raise that to the power of 3. It gives us x to the power of 6. And then -2 to the power of 3 is, of course, -2 times -2 times -2. And we get -8. Again, if you write this as -x squared over 8, x to the power of 6 over -8, or -x6 over +8, those all mean the same thing. So this is probably the tidiest way to write that answer.
So these last 2 examples have a little bit more going on than the previous ones did, but we're using exactly the same properties of exponents to solve each one. For the first example, it's the first one that isn't presented as a fraction, but actually the very first step we're going to do is to turn it into a fraction. And that's because if I look inside the brackets, I have a y to the power of -1, which tells me that I'm going to pick up that y, the base of the exponent, and move it to the other side of the fraction line. The -8 and the x squared, on the other hand, are raised to positive exponents. -8 is basically raised to the power of 1, and x, I can see, is raised to the power of +2. So neither the -8 nor the x squared leave the denominator. It's a good time to remember that the -8 and the -2 are very different numbers. The -8 is the same -8 number that we're familiar with, the regular negative numbers. It's only the negative exponents that have different meanings. And -2 is really the product of -1 times 2. So when we have a negative exponent like -2, anything other than -1, we really have 2 instructions there. Is there anything else I can tidy up inside the brackets before I look to that -2? No, there isn't, so it is time to raise it to the power of -2. And again, I'm going to do this one at a time. So I'm going to raise everything inside the brackets to the power of -1, which I know just means everything in the numerator will end up in the denominator, and everything in the denominator will end up in the numerator. So I know I'll end up with y over -8 x squared. And so we've raised that to the power of -1, but not yet to the power of 2. If you see where this is going, go ahead, pause the video, finish the problem, and I'll catch up to you. I always encourage you to give these problems a try before we do them together. In any case, we have one more step to go here, and that's to raise everything inside the brackets to the power of 2. And the only one we really need to be careful of here is this -8. Be sure to tuck that -8 into brackets because both the negative and the 8 should be squared. And then the x is already squared. We're going to square it a second time. So as a final answer, when we tidy it up, we have y squared divided by positive 64 and x to the power of 4.
And finally, let's look at the big one. Of course, again, there's nothing new going on that we haven't seen in the previous problems. We'll attack it piecewise again. So I'll look at the 4 and the -2 separately from the x's, the two y's, and the single z. And of course, I'm going to look inside the brackets first and fill in the simplified fraction, and then we'll worry about raising everything to the power of -2. All right, so we've got the 4 and the -2. Again, that -2 doesn't mean we need to move the 2 anywhere. It's just a regular negative number. I can think of this a couple different ways. 4 divided by -2 is -2. Or if you like, you can write that as -2 over 1, or even as -2 over 1. Because if there's no explicit denominator, we know there is a denominator of 1. Or maybe you've thought of it as 4 divided by -2 and looked at both and said, okay, both are divisible by 2. 4 divided by 2 is 2. There's a 2 left in the numerator. -2 divided by 2 is -1. So there's a -1 left. So what I'm trying to show you here is that regardless of how I write it, -2, -2 over 1, -2 over 1, or 2 over -1, those all mean exactly the same thing. So choose your favorite. In fact, maybe this time I'll write the negative out in front of the fraction because we don't often do that. In any case, the 2 goes in the numerator and the 1 in the denominator. So moving on to the x's. We've seen this a couple times. X to the power of 3 over x to the power of 5 gives us 1 over x squared. If you're not sure how, look at the previous examples. There's an x squared left in the bottom. What I do want to spend some time on is this y to the -6 divided by y to the -4. A couple different approaches, of course, here as well. If we go strictly by the properties of exponents, I would write y, and then I'll take the top exponent, the -6, and subtract the bottom exponent, -4. So y to the power of -6 minus -4 is the same as to the power of -6 plus 4. So we get y is equal to the power of not 6. Y is equal to the power of -2. Of course, nobody likes negative exponents, least of all math folks, so we're going to rewrite that as 1 over y squared. But that also lets us know that we have 2 y's left over, and where are they? They're in the denominator, right here. Maybe you didn't reach right for the properties of exponents, and that's fine. Lots of different ways we can approach this. Maybe you said, okay, the top y is raised to a negative exponent, so that top y, in fact, all 6 of them, will end up in the denominator. And y to the power of 4 is actually y to the power of -4. That negative simply tells us to pick up the y and move it to the other side of the fraction line. So maybe you look at that as y to the power of +4 divided by y to the power of +6. And now it is a little bit easier, in fact, to apply the rules of exponents, and we'll still get 1 over y to the power of 2. Or maybe you're thinking of it as 4 y's in the numerator and 6 y's in the denominator. That may still be easiest for you, and that's absolutely fine. Of course, it's taken me away from our slide, so here we are back again. In any case, we have 2 y's in the denominator. What about the z? There's only a z in the denominator, so it stays there, z to the power of 3. I'll do the same thing with this question as we did to the previous one, and I'm going to raise it to the negative exponent first and worry about the 2 later. So there are my brackets. I'll leave that as to the power of 2. Of course, the negative exponent simply means we're going to flip this fraction on its head. We're going to take the reciprocal. What was in the denominator moves to the numerator, and what was in the numerator moves to the denominator. Has not affected the negative 1. Now, as a last step, I will raise everything, the x, the y, the z, the 2, and the negative 1 to the power of 2. We have x squared, we'll square that. Y squared, we'll square that as well. And z cubed, squared. And finally 2 squared. X to the power of 2, all raised to the power of 2. What does my rule of exponents say? Just as an aside, the rule of exponents here says if I've got a base raised to some exponent m and all of that is raised to an additional exponent, I am, of course, multiplying my exponents. So x squared, all squared, is x to the power of 4. Same goes for the y, and the same rule applies to the z. 3 times 2 is 6, so I have z to the power of 6. 2 to the power of 2, 2 squared is, of course, just 4. And then finally, this negative 1, well, what I've really got is negative 1 squared, which is just positive 1. So we get rid of our negative sign entirely that way. So my final answer is x to the power of 4, y to the power of 4, z to the power of 6, all divided by 4.